Kale, hey, join in here. We just got started, okay? You really haven't missed anything, Kale.
You're screwed, Kale.
You know, I just realized that. I was talking to, we were just talking to Kale right there, and I literally looked at his desk to talk to him, like that.
Break 51 class.
Okay, 7, 10, 13. Okay, so 7, so it'd be written like that, right? And you don't have to write the 1, 2, 3, 4 underneath it. Okay, but that's what we're saying. And so we call this the first term. We call this the second term. So when we talk about a sequence, we talk about the terms of the sequence. So this is stuff Mrs. Payne talked about yesterday. But there isn't a video of it. So for those who are gone, I want to just touch on it a little bit. So first term, second term, third term, fourth term, right, of this thing. And here's how we would write. And we would call this an nth term formula. Okay, so that's called an nth term formula. So it's very much closely related to our old function type notation. It's just a special function where the inputs are always 1, 2, 3, 4 or 0, 1, 2, 3, 4, just the integers, the positive integers. Okay, so that's called an nth term formula. So we say a sub n. So if we wanted the 100th term, we'd put 100 in, that'd be 304. So we would say the 100th term would be 304. That's like over here saying what's f of 100. Right? Same idea. Okay? All right, so that's what we're going to look at when we talk about these sequences. Sometimes we start with 0 instead of 1. Okay, we're going to be getting into what we call infinite sequences, so they just go on indefinitely, versus a finite sequence where we just have, for example, 8 terms, in this one. Okay? A sub 4, again, we call the fourth term. A sub n is the nth term. All right, so here were a couple. So on your homework, one of the things you had to do is write the first 4 terms, or write the first 5 terms of the sequence. Well, it's very easy. You just plug in a 1. You plug in a 2. You plug in a 3. You plug in a 4. Right? That's all you do. Same thing here. Plug in a 1. Now, when that's in the power, it's like an exponential function, but -1 to the first is -1. Okay? -1 to the second is +1. -1 to the third, again, is -1. -1 to the second is +1. And then this pattern just continues. 2, 4, 2, 4, right? And so what's happening is we add on a 1, then we add on a -1. Add on a 1, add on a -1 to that. But that's pretty simple stuff, just plugging in numbers. So the nth term formulas generate the terms of the sequence, okay? Then we introduce this idea of factorial notation. Have you seen that before? Okay, you've seen that before. So 6 factorial, or you can write it this way. Doesn't matter, it's multiplication, right? You can go any order. Just understand the n, when you go up from n, it's n plus 1, n plus 2, n plus 3. You go down from n, it's -1, -2, and so forth. Okay? By definition, just got to know 0 factorial just means 1. Okay? 0 factorial is just 1. Okay? Nothing really works if you don't. Okay? There's a difference, just like exponents and other things, there's a difference where the parentheses are, right? Here, the factorial is only on the n. Not on the 2, right? It's kind of like if you had 2x cubed. The cubed is only on the x, not on the 2, right? Unless you put parentheses around it. So that's important to understand. Okay? All right. And so you just had some things where you had to plug in ends. I'll just do this one real quick. When we simplify these things, a couple with factorials, a couple things. One way to do it is to write it all the way out and do canceling. So this would be 2 times 1, and then it would be 6 times 5 times 4 times 3 times 2 times 1. So you can cancel a bunch of stuff, right? Now, you do enough of these, and you start realizing, well, geez, 8 factorial divided by 6 factorial, the 6 factorial will take care of everything from 6 on down. 8 and 7 is all that will be left, right? But there's no harm in writing it all out. That's fine. And so you got 56 on top, 2 on the bottom, and for a total of 28. Okay, so it's fine to write it out. Now, where you might not want to write it out is if you have 100 factorial divided by 97 factorial, right? I mean, writing it out would be kind of a pain, right? Well, what's going to cancel? 97 on down, right? 97 on down. So all that's going to be left is 100 times 99 times 98, right? So, you're not always going to be able to write everything out. Okay, so again, here was just some more practice that we did, writing some things out. Okay, find the indicated term. You want the 16th term, just put a 16 in for n and find it. Okay, did you guys go over these in the book? These are some problems in the book, just kind of match the graphs. They're just individual dots because when you have a sequence, you're not connecting them. There's no inputs in between. In algebra class, you do a 3x plus 2, you would graph the whole thing. Even though you let x be 1 and a 2 and a 3, x could be 1 1/2. X could be 2 1/2. Not with sequences, though. There is no 1 1/2 term.
She told us that it's only integers.
Only integers for the input. She said that?
From the beginning.
Right.
Never messed up
Beginning
one.
of
Beginning
class,
of
she said
class,
that.
she said that.
We didn't mess up one. She was perfect.
Okay.
Yeah, that's all she
Why are
said.
you telling me? Okay, so that's right. So there is no term and a half, right? First term, second term,
Confused
third
with
term.
anything else, that's all we heard.
Yeah, well, good. All right, so any questions on the homework? Let's take care of those right now.
So whenever there's an n factorial, you have to write that whole thing.
So give me an example.
So 82,
82. So what's 82? So?
n plus 2. Okay. So n plus 2 factorial over n factorial. So say if you're gonna write it out, what?
So it would look like this. So n plus 2 would be the biggest one, right? Times, what's the next one down? N plus, no. You're going down, right? So if you have n plus 2, the next one below that would be 1 less, so that'd be n plus 1. The next one would be n. The next one would be n minus 1, and it would keep going, right? N minus 1, n minus 2, n minus 3, on and on and on. Okay, what's n factorial? Starts with n.
N minus 1.
The next one down is n minus 1.
N minus
And isn't that going to be
2. It's gonna cancel all of it.
all of these, right? This will be n minus 2, right? And so forth, so on. So they'll just keep going. So once you get down n plus 2, n plus 1, once you get down to n, everything below there will cancel with everything else. Makes sense? Okay, so what are you left with? You're left with n plus 2 times n plus 1, which I'm fine with you just leaving that. You can FOIL it out if you wanted to, but that would be it. Makes sense? Okay, what else? Anything else? So that assignment was mostly about just plugging in, finding this term or writing the first 5 terms, plugging numbers in, getting those, and generating those sequences. Okay?
Can you go back to the notes on that?
On,
The end.
I don't know where you're talking about.
Yeah, and then you have that big page. Yeah, you're like a big page. There you go.
Yeah.
Oh, should I write that to the end?
Now, on the note that on this very last one here, the very last one on this page, I wrote it backwards from what you normally would do, right? I mean, this would be 2n factorial. A lot of times we always, like when we do 6 factorial, we usually go 6 times 5 times 4 times 3 times 2 times 1, but you can go the other way, 1 times 2 times 3 all the way up to the top, right? And so that just seemed easier with an n in it to go that way. Okay, but you could write it this way, 2n. What would come right before 2n, or excuse me, what would come right after, if you're going down, what would come right after 2n? 2n minus 1. And then 2n minus 2. Now you would keep going, but you don't know what n is. You could keep going 2n minus 3, 2n minus 4, whatever. But eventually it's going to get down to what? 3, 2, 1, right? No matter what n is, eventually any one of these is going to get down to 3 times 2 times 1. Okay? I mean, so that's why I just wrote it the other way. I just started at 1, 2, because I didn't know what 2n was, and so that'll be at the very end. So you could write it that way too. All right. Okay. Anything else? All right. So we got just enough time to go through a couple of examples here, so we can use most of the time after lunch to work from it. Yeah. Again, I'm going to put this up on the website too. All these pages here. Okay. I'll just add this on today's homework today's homework page. I'll add this file. Okay. All right. So let's write down these 3 basic patterns. These are 3 basic patterns. There are other ones, and there might be some other than these 3 that may show up in the homework, and so you're going to have to be a little creative, and there'll probably be some questions on Monday on a few of these things. But there's 3 basic patterns. Okay, this first one here is what I would call repeated addition. Now remember, addition, subtraction, we can use those interchangeably, right? If you add -3 to each term, that's the same as subtracting 3, right? So repeated addition, we could be adding on a negative or a positive, but it's still the same thing. Okay, well, what are we adding to each one of those? 3. So therefore, you would think right away what? 3x, or since we're doing nth term, 3n. So if I was doing this, I would start. Now, I like to put these numbers down at the bottom. Let's assume n is starting at 1, unless you hear or see differently in the problem. So below this, I like to put the n, okay? First term, second term, so forth. Okay, well, if I start with 3n, that actually gives me 3. And then 6. Well, what do I notice? It's too short, so I need to add on 2. So that's the thought process in finding that nth term formula. So if you get a problem that says write or find the nth term formula for this sequence, you're looking for the pattern, and then you're writing one that will generate these terms. So you look for the basic patterns. One of them, the simplest one, is repeated addition. Repeated addition makes you think multiplication by that number, and then you adjust it with adding on whatever you need to get those terms. Okay? Here's the second basic pattern, and this is what I would call repeated multiplication. Okay? If you notice this one, and again, division would come along with this. If you repeatedly divide by 2, if those terms were dividing by 2, what you'd say is, well, you're multiplying by 1/2. Right? So dividing by 2 is the same as multiplying by 1/2. So when we say repeated multiplication, that takes care of division also. Okay? Well, here we're repeatedly multiplying by 2. Now, what is repeated multiplication by definition? Well, it's not repeated. It's just repeated addition is multiplication. Repeated multiplication is exponents. That's what exponents are. Right? So if you have a 4th power, if you have 2 to the 4th power, that's 2 times 2 times 2 times 2. So repeatedly adding something is multiplication. Repeated multiplying by something is what an exponent is. So when we see repeated multiplication of 2, we think 2 to the nth power. Now we might have to adjust that, right? So repeated multiplication by 2, we're going to think 2 to the nth power. So again, let me put my n's down here. Okay, well, if I do 2 to the nth power, that's going to be 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th. Well, that's 2, 4, 8, 16. Now, what do I notice there? How do I adjust 2 to become 3, 4 to become 6, 8 to become 12, 16 to become 24? I can't add on, right? I can't add because that would be like, what's that? Well, there's 2 ways you could do it. Well, one way to do it is you could divide. You could say, okay, well, let's see. 3. What's 3 divided by 2?
Plus 2.
Not plus 2. Well, wait, maybe. No,
No, because first one.
first one would work.
Why not?
Well, plus 2n would be plus 2, so you'd have 2 plus 2 would be 4. We'll finish it up. Finish it up when we go back.
I'll take it into consideration. You're kinda like the way you did your hair.
Why did you do it?
I was gonna say like.
Thanks. Oh my God.
Bye.